Hi, my name is Rishit Sarkar, and this is my lab report for Lab 1. So the purpose of this lab is to use charged pieces of tape to observe interactions between charges and to estimate the amount of excess or deficient charge that reside on a piece of tape. So the models that we were using is Coulomb's law to model the forces exerted between the point charges, being forces equal to constant times Q1 times Q2 over r squared times r hat. And then we're going to be using Newton's second law and the gravitational force, being force equal to ma and force equal to mg, to help calculate for charge using the conservation of charge and energy. So the main results from this lab is that the charged U-tapes repelled each other since both tapes had the same charge. The U-tapes have a positive charge because it was attracted to a negatively charged pen, and that the calculated charge for one tape is 1.4 times 10 to the negative 9 coulombs, and the number of deficient electrons is 8.75 times 10 to the 9. So for this experiment, the charged piece of tapes are simplified using point charges to show the attraction and repulsion between the pieces of tape. And so assumptions made is that the electrons are evenly distributed, each tape has the same charge, and that when the tapes interact with each other, the upper tape is in equilibrium. So for the system in this experiment are charged tapes A and B, and the surroundings is everything else, including the Earth. Our initial conditions include the length of the tape being constant at 0.2 meters, the mass of the tape being 0.0002 kilograms using the ratio 1 gram per meter, and the acceleration due to gravity is 9.81 meters per second squared, that each tape begins uncharged. So this experiment was carried out by first placing a base tape onto the table and then adding a U-tape that was stuck onto the base tape and quickly peeled to create the charged tape. The charged tape A was placed near other objects to determine the charge of that tape. Then a similarly made U-tape B was created, and the interaction between both of these tapes was observed, and the distance repelled or floated between the tapes was recorded. So our observations include that the U-tape was attracted towards a neutrally charged item and a negatively charged pen, and that U-tape A made U-tape B float upwards by 0.003 meters. So based off how U-tape was attracted towards a negatively charged pen and repelled from a similarly made U-tape, it is safe to conclude that the U-tape was positively charged. So our calculations is that the force due to gravity is found using mg. So we take the mass of the tape times gravity to get our newtons as 0.00196 newtons. And since, as I mentioned earlier, that tape B would be in equilibrium, we can help calculate for the electric force. And since in equilibrium we're going to have an acceleration of 0, that means we can safely conclude that the gravitational force is equal to the electric force. So the electric force is also 0.00196 newtons. And using that, we can set both of these values equal to each other to help isolate for the charge Q to get 1.4 times 10 to the negative 9 coulombs. And then we can help calculate for the number of electrons by dividing by the charge to get 8.75 times 10 to the 9 electrons. And then we can take the area of the tape and we can divide that by the ratio of the length squared of the atoms to get the number of atoms. And then we can take electrons divided by atoms to get 2.19 times 10 to the negative 8 electrons per atom. So this is our code that I use to help model the point charges and the electric force and the gravitational force between both of the charged piece of tape. So some similarities between the code and the model is that the value of the gravitational forces are the same, the value for the charged tapes are the same, and the value for the deficient electrons is the same, as well as the ratio is the same. Some discrepancies is, however, since the tape was modeled using a single point charge, it is not truly accurate, but it is simply done for simplicity. And we had to assume that the charged pieces of tape were the same, and that the dimensions and distance for the models is exaggerated for better visuals, and that the air resistance is negligible. So what if electrons had positive charge and protons had negative charge? The observations made with the tapes and the other charged items would remain the exact same, because opposite charges would simply be swapped, but the property that opposite charges repel and similarly charged charges would attract would remain the same. And so why is it important to handle the charges with as little as possible? Well, because the charged tapes become discharged when interacting with other neutral items. And that when the tapes come in contact with hands, the tapes begin to lose their charge since the charge is transferred between the tape and the hands. So some possible sources of error include that the tape was handled too much by hands, causing the charge not to be as strong. Another possible source of error is that the tapes are not ripped with the same speed, so that both charges are not the same. Another possible source of error may be due to human error in measurements, so the tapes are not accurately 0.2 meters, or did they not accurately float 0.3 centimeters. So some final thoughts for this lab is that this lab was able to show how pieces of tape can be used to model point charges to show how charges interact with each other, and that the pieces of tape can become charged and the tapes in this lab were found to be positive, so that they were attracted towards negatively charged objects and repelled from positively charged objects. Thank you so much.